One, two, test, test, one, two. Terrence? Well, maybe Terrence. welcome everyone. Welcome everyone. I think the mic is... Welcome everyone. Hey, welcome everyone. Welcome. Welcome to our first day of the Staking Gathering event. I'm glad to see you guys all came here. It's very fun to see a lot of familiar faces for this event here. First of all, I'd like to thank our sponsors for which we're very glad for. So if you haven't seen the sponsor booth, make sure to go and check it out. This event would not have been possible without our sponsors, so just make sure to check them out and see what they have to tell you. I'd like to also thank the Ethereum Foundation for all their work and what they did with us. It's amazing what they could do for us in this venue. This venue is like so beautiful. I like it a lot. So we have to thank them for this. If you guys have any project idea that are related to staking, we have this hackathon on April 21st. So make sure to join. We have a lot of nice prizes. So we have like 10K USDC in terms of prizes. So like even if you have like a small idea, it could be very fun for everyone. And like we'll have all the setup for you guys to work. Like we have whiteboards and tables and Wi-Fi and everything. So like if you want to join, we still have like a lot of room for you guys. Now, let's go with our talk. So our speaker is a developer for Prismatic Labs. So please give a round of applause for Terrence.
Thank you. Yeah, thanks for the warm intro, and thanks to everyone for coming. I am very excited. So what could go wrong at the merge? So I'm Terrence. I am from Prismatic Labs. I work on Prism. It's a consensus layer client written in Go. And yeah, I'm just super excited to be here. Thank you, eStaker, for hosting such a wonderful event. And yeah, thank you guys for coming. So what this talk is about, so I'm gonna give a quick refresh. I'm gonna give a quick refresher of the merge, what is a merge, and then I'm gonna dive into some risk assessment that I think like things may be going wrong-ish, maybe not, and then I'm gonna go to the bugs, I'm gonna go to the risks, and then most importantly, I'm gonna talk about what we can do about them. So the merge is coming, whether it's in July, in August, September, the merge is coming, and that's the date, right? So besides the date, what's more interesting is like, what are the risks, right? What are the worries? Like as we get towards the merge, like what should we be thinking as a developer, as a community member, as someone that has been waiting this probably their whole life? So before we dive into the risks, let's talk about what is a merge, right? The merge replaced proof of work with proof of stake. Today, we have two parallel chains, one running proof of work consensus, running proof of stake consensus. Proof of work consensus embeds the user level transactions. That's where the DeFi, that's where the NFT stuff is, that's where the fun stuff is, right? Then you also have this proof of stake consensus that's running in parallel. That's where the validators hang out and stuff. So the merge basically means that we say goodbye to the proof of work chain, and then we merge everything from the proof of work chain to the proof of stake chain. So what that means, if you look at this picture, that just means that you have one Ethereum chain that's secured by proof of stake, and then underneath there, there's an Ethereum state tree, there's all the EVM, all the dApps and layer 2s, and they're all secured by the proof of stake consensus. So what that means, so before we talk about risk, let's quantify that with some numbers, right? So roughly how grand, like how important this update is. So I took this screenshot, I look at what's the TVL for DeFi, layer 2s, add them together, facing April 8th, it's around 85 bill. And then of course this is a preliminary number. I mean, there's probably something that I've missed, but that's a lot of money, right? If you think about that, and that is what we're working with. Then let's talk about what is new in the merge. So right now, today, if you're a home staker, you run your consensus layer clients or so-called beacon node, whether it's Prism, Lighthouse, Nimbus, or someone else, then you run your execution node, whether it's Get or Nethermind. So you run your execution node because you want to pack your deposit. You want to be a good citizen. You want to induct new validators, right? That's why you run them. But post-merge, this becomes absolutely necessary. You have to run them. But why do you have to run them? You have to run them to verify user-level transactions. You need to run them to propose blocks. So this becomes absolutely mandatory. If you don't run them, your validator will just seem like it's an offline validator. It's pretty much useless, right? So let's go through the interaction more in detail. Like, how do the consensus layer client and the execution layer client, they talk together? They talk to each other to verify information such as user level transaction. They talk to each other to basically set head. So the execution client know what is the head of the chain. And based on the head, they can do like many other things. They also talk to each other to exchange transition configuration so that they are on the right chain. So if they're not on the right chain, then there's pointless to basically even talk to each other, right? And then post-merge syncing becomes a little trickier as well, given that two pieces of software are very closely coupled. There's this native lockstep sync basically says that as a consensus layer client and the execution layer client, I'm always syncing next to each other. I'm verifying block one by one. And then what the pros and cons? So the pros is that this is very easy to reason, right? But the cons with that is just that the UX kind of sucks. You need both pieces of software to always be running next to each other. They both have to be synced to the head of the chain. Then there's this so-called optimistic sync. Basically, it just says that, hey, as a beacon node or consensus layer client, I can sync to the chain first, and then I don't really care about what the execution layer client is doing because like they can sync their own way. They can do their fancy snap sync, like fast sync. But the pros and cons with that is just the pros, the UX is nicer, but the cons with that is just that there's beacon node, you cannot do many things because you cannot verify your payload. So that's a trade-off. And this type of syncing algorithm opens like new set of risks, which I will go through as well. So what is risk? To me, risk is something that's likely to happen multiplied by something. If that happens, what's the impact? So risk is likelihood times impact. And ideally, you want something that's as low as possible in terms of the scoring. So if you look at likelihood, 1 is just not possible, meaning it's not going to happen. 5 means that it's happening right now. And then if you look at impact, 1 means there's no consequence, but 5 means that it's catastrophic. There's no discovery. So you never want to see a 5, basically. Now I'm going to go through a set of bugs that I think could be risky, and then let's just go through them one by one, and then I'm going to convince them like why they are the way they are. So the first bug is consensus bug. So this is probably the next important slide right now. I'm going to convince you guys why consensus bug is the worst bug. It's like the final boss. You never want consensus bug. And then one example of consensus bug is what we call invalid state transition. And so what that means is that when you process a block and then the state differ from the correct state. And then one example of that is just you're minting ETH out of like fresh air. Basically, in the bottom example, validator 3 got an extra 66 ETH, and then your validator 3, you could just go to exchange, withdraw it, or go to the online mixer, send someone else. And this gets uglier in a way because like in a proof of stake system, there's this notion of finality, right? If something that's invalid that gets finalized, what that means is that in order to like revert the chain back to the correct state, 1/3 of the validators will get slashed, or you have to wait for them for their balance to drain, and then they get ejected. And then that's just very, very ugly. We never want to get to that point. And the same goes with execution state as well. So this is why client diversity is very important. You don't want a majority client over 66% because a bug could be finalized, whether that's on the consensus side or on an execution side. So that's consensus bug. So I hope I was able to convince you guys why consensus bug is terrible. So, but what is the likelihood of that happen? Possible. No. But not really expected. But when it happens, it's catastrophic. There's no recovery. So let's just give that a 10. Now let's chat more on other type of bugs, right? So one bug is just your validator is voting on incorrect head. And we do see that today already, usually after the first slot of the epoch, because beacon node is processing epoch, it takes a little bit more compute power, then you miss your head vote. You vote incorrect head. That usually happens today, and it's gonna happen probably more post-merge just because of there's more compute, there's more computation to be done. And when that happens, the UX usually defer-ish, but then the impact of that is generally acceptable among the community because you lost your head vote, which probably doesn't cost that much money. But the likelihood of that happening is kind of expected. So let's give it a 6. Then the next type of bug is what we call offline bug. So that just means that your validator cannot propose, your validator cannot attest. And it's funny because Prism actually had that bug 2 weeks ago on the Kiln testnet when we incorrectly marshal one of the execution payload. We used the wrong Indianness. So from the correct validator's point of view, it just seems like your validator is offline, and that's it, right? And then if your offline validator is not that heavy in terms of network share, then it's generally okay because the other working validators can pick up the share. So the likelihood of that happen, plausible, not expected, but when it happens, it's unacceptable. People will be pissed. But it's also recoverable because you just need a software update. Client dev will be pretty quick to patch the software and then do a release, and then you upgrade your client and you're good to go. Then the infamous slashing that everyone is scared about, right? Slashing happens due to user level misconfiguration, whether you're running two separate keys on 2 different locations, or you made some fancy setup in terms of configuration, and then you accidentally get slashed, right? But in order for that to happen on the software implementation level, it's very, very, it's very, very less, just because with all the slashing happen on the mainnet today, none of them are due to software bug. Every single one of them is due to user configuration, or they do some advanced setup and then screw something up, right? So the likelihood of that happen is 1. It's not going to happen. And then the impact when it happens is 5. It's catastrophic. There's no recovery. So hope I was able to convince you guys why consensus bug is bad and then why client diversity matter, which I will go more into that later. So besides bug, what are some other risks that's not code related, right? I think one of the more important one is just really bad UX. If we made the nodes, they are very complex to run, then we'll lose at home staker, we'll lose individual node operator, then we'll see more centralization through staking providers, we'll see more centralization through infra providers. If we have unclear documentation, then people make user errors, and then they lead to rush decision, people panic, and people accidentally get slashed, or accidentally launch 2 setup at 2 different places and then get slashed. So to me, poor UX is almost as bad as a really bad bug, just because it is expected as of today, just because the UX hasn't been that good. And then when it happens, it's also unacceptable. So I will rank that pretty high. Then there's also the network attacks. So such as like, if you like find some language-dependent resource exhaustion bug, you should do attack on a specific client. But even when that happens, you can always switch to different clients. So client diversity again wins here. Then you can do denial of service on a live network. But then from an attacker's point of view, that's very costly to run, but it's also very disruptive to the network. So it's plausible, but it's not really expected for the DOS attack just because it's very costly to run, and there's always like client diversity that they can save us. And then the impact of that is also acceptable because like we have planned for that. Client software has built-in defense on that. So it's pretty low. 2 times 2, 4. Then there's also the social engineering attack, right? As we get towards the merge, we'll probably see more scams, more phishing. We'll see people attempt to compromise on major sites like the Launchpad. You'll probably see more like fake Vitalik on Twitter and stuff like that, just because the merge is happening, it is a big event. So that happens today already, right? It's common, and then it's gonna probably happen a lot more towards the merge. And then the consequence of that is usually acceptable today. You're kind of on your own, right? So the multiplication of that is 8. So it is quite high. It's probably next to poor UX. Then there's always the minor revoke because minor controls the total terminal difficulty. So minor can theoretically know when the merge will happen, control when the merge will happen. So it's important to monitor minor sentiments. But on the software layer, we have mitigation plan. We can always merge based on terminal block hash and activation epoch. So we also have defenses against that. So it's plausible. It's not really expected. But when it's expected, it's also recoverable with a little effort. So yeah, going through all the scenarios, I would say bugs and poor UX are our worst enemy at the end of the day, and that's why testing client diversity is really important. So enough like bad news, right? What is our strength at the end of the day, right? Our strength is every single one of you. We have an amazing community right here. We have multiple client implementation. Thank you, client diversity. We have world-class researchers, developers, and then we are thriving on testing as of today. So client diversity, there are 6 amazing consensus clients out there, 5 amazing execution clients out there. Please try them all. Like, give them your feedbacks. Like always test them. Like always experience, because there's just so many different combos you can try. And then client diversity captured on April 9th, and then Prism is falling below 50. And as someone that works on Prism, like I'm actually really proud of this. It's actually to see how far that we have came to. And then, but I do still think that we can still do better. I still like to see the ratio be more even. And the same goes to execution client as well. And I believe Geth is like over 80 right now. So yeah, the same applies to them. So testing, we have a lot of testing progress in parallel, such as fuzzing, such as stress, using larger block size, using shorter slot time. We are shadow forking every 2 or 3 times a week, so we can see how our software combos behave on a live production environment. And then we have 90 CI/CD on just running through all the client combos. So what can you do? At the minimum, you can protect yourself. Use 2FA, have a very, very strong password. If you see something that's fishy, you see scams, report that. Stand up against fraud campaigns, and then spread useful information, news. People will appreciate that. If you want to be more adventurous, you can participate in testnet, preferably use a minority client. You can review documentations, provide feedbacks. If something is unclear to you, that means it's not unclear for other people as well. And then you can write user documentations, and those are very, very nice things to do. If you want to be really, really adventurous, you can explore different failure scenarios. Try to break your client. Try different client API endpoints. Measure the client performance. And then most of the time, like usually this type of activity, will lead you to like a bounty or like a part-time position or even full-time position. So if you wanna like be a protocol dev, this is a very good stuff to basically get your foot wet. So on the fly here, I was thinking like what I would build for this hackathon, and I came up with some hackathon ideas. So if anyone's interested, you can build a monitoring system, monitor individual client, staking pool, monitor when the merge will happen. You can work on redundancy, failover, like Vultr is a good example of that. You can work on testing, and then you can work on live client, which is a very underrated topic as a day. So that's all I had. I hope I was able to convince you guys like what are the important things to work on, what are what are the risks, and yeah, I'll be here to answer any questions. Feel free to come talk to me, and my team, Raul and Preston, are here as well. So yeah, thank you guys so much for having me.
Terence, do you want to take some questions from the audience?
I'm lost.
Is there any question? Anyone? I'll come to you.
There's a lot of focus on the client diversity on the consensus layer, but not so much on the execution layer. Is there less risk involved?
No, that's a good question. First of all, it is almost the same amount of risk. It's not less because everything is under one chain, right? So your consensus state also reflects the execution state. So when there's an execution level state transition bug, that thing also gets finalized through consensus as well. So it is a very good point. It is very important, and we need to get on that. Yes.
Is there anyone else who has a question?
Hi, I have a question. You mentioned that maybe we can help with testing, for example, validators and stuff. But to start a validator, yes, it's like more or less, I would not say easy, but like anyone can do it. You have a lot of materials online. But what about test is? Like you need 32 test is to run one validator.
Exactly right. So it depends on where the test net is. So for the merge, as of today, there's, for example, Kiln testnet. That is pretty easy to get test ETH, and that's the merge testnet. But I do see your concern once we're in Goldie or something like that. So there's a proposal right now by Alfred that's minting a lot more Gold ETH. So first, it's good because it makes people will not exchange Gold ETH for money. Second, it's good just because we can spread that around more. So yeah, so I think there will be a lot more Gold ETH for people to test. But today is hard. I totally agree with you.
Any other question? I think that's pretty much it. Please give it up for Terence. Our next talk is scheduled for 2 p.m. So if you guys want to hang out, maybe you still have some room for the next talk.
really missing is that's the other end of the scope. So between it's hard to have it.
So hot walking up there. Get one? No. I didn't even try it. I thought with first going into anyone, totally wrong.
Check the weather, you just tell like it.
Yesterday I was checking glass and I was like, oh, it's going to rain. And I was actually a little bit of rain on Monday.
Should be a lot worse.
So what was going on there? I was only up there to have the bike up, and then I was like, fuck this, I need to go back to the hotel and shower again. Just to see it.
Interesting discussion about people that talk from the beats on his website and he said something about security. It's not true! And you get something you kept going. So it can't be like, I think the other thing is still one of those that what's going to happen play out.
Yeah. There are certain actors within L2 that I feel like are quite immature and very childish with the whole thing, rather than like just product acknowledging these are the trade-offs and downfalls. Everyone's like trying to mask that and hide that and just completely contrary to what we're trying to build on mainnet.
Do you feel like there's strong competition to see who's going to win the race for that might be a lot of stuff.
Yeah. I feel like optimism and arbitrum, like as far as generalized outcomes, are like already have that network effect and already have like a good team that will probably come out on top, but like everything could change. I don't know. I like purpose-built L2s like kind of college L2s, but like things like Immutable and even I think like Polygon is slow just now for onboarding people, but me and Paul were speaking about it yesterday. The worry we have is like if we get too many people on that, then it's like we have to migrate them from that to something else, and if the infrastructure in place, and at that point Polygon's already got bags full of money with it. Just keep everyone on by running some sort of incentive program or just by sheer marketing, or the fact that people are already on it and happy with it, and it's like people won't, the catastrophe won't happen until it happens by that point.
Let's try to see what happens. Thanks very much.
Welcome back. Welcome back, everyone. Welcome back. So our next speaker is a researcher with the Ethereum Foundations. Please give a good round of applause for Blogway.
Hi everyone, my name is Blagoy and today I'm going to talk about consensus layer, validator privacy and anonymity. I will go over the importance of consensus layer validators, the current state of their privacy, and on the stuff we're working at to improve this. So the validators are the main entities responsible for bringing network to a consensus. They have different roles and perform different duties according to the protocol, such as block proposals, attestations, aggregations, and some others. For one to become a validator, they need to stake a certain amount of ETH. And also, like, penalties and rewards are applied based on the duties they perform or the correctness of their duties. Because of their role, of their importance, it's very important for the validators to have some anonymity. And there is anonymity or pseudo-anonymity on application level, but we also need anonymity on network level. This is quite important because of DDoS attacks on the validators. Actually, anonymity is important for preventing this kind of attacks. And DDoS attacks are possible by discovering the validator's IP addresses via network metadata analysis. And also it's pretty important because of the personal privacy of the validator operators. And additionally, if DDoS attacks are performed on the validators, then the network can come to a stall. Because let's say if block proposers are DDoS, then there is no one to propose a block, no attestations, and there could be a stall to the network. And the network currently works in a two-component model. So we have validators and we have beacon nodes. So virtually they are separate entities. They can run on the same machine, but they can run also on different machines. And the validators can use a trusted connection to the beacon nodes, and they actually send the signed consensus messages to the beacon nodes. And then the beacon nodes are connected to the peer-to-peer network, and they propagate the messages through the peer-to-peer network. And because the messages are idempotent on network level, the validators can be connected to multiple beacon nodes and send messages to multiple beacon nodes. And there is some work done on this topic. So on peer-to-peer level, the messages are using strict no-sign policy. So there is no signature on the messages, there is no from field, and that kind of stuff. But metadata analysis attacks are still possible. So this is possible by inspecting, let's say, the beacon node traffic, so the input and output network traffic, and determining the validator IP addresses. And by idempotency, so for example, if a validator is connected to multiple beacon nodes, this is a bit harder, but it's still possible. And at the privacy and scaling explorations, we have been working on an improved solution for this problem. And also, like previously, a lot of research has been done, but currently nothing is implemented, I think. And this research included solutions like onion routing, mesh networks, Dandelion, and other solutions. And basically, the goal is to obfuscate the message sender. So the implementation or the research of this solution is to provide that. So basically, to hide somehow like who sent the original message. So it's not known, and the validator's IP address is hard to find. Or in other words, like unlink the message sender from the message. And the main problem with this implementation is the latency, and also like the problems of technical implementation. But the latency is the crucial thing here, because if latency is not respected, then penalties are applied for the validators. So what we have been working on to achieve a better anonymity is also a private opt-in network. And in this network, only the validators can send messages. And to be part of this network, validators should register upfront. And the condition is that they are an active validator. And there are actually multiple approaches for this implementation. One simple solution is to use the same gossip SAP implementation. So that's the peer-to-peer protocol that the beacon nodes are using. And obviously the goal is to obfuscate the validator's physical IP addresses. We've been working on Dandelion, so that's a method to achieve anonymity in peer-to-peer protocols. And we've worked on modified gossip SAP version that implements Dandelion. And the goal here is that the messages are passed through the network, so they travel, let's say, multiple hops before they are being propagated as consensus messages using the normal gossip SAP. And this obfuscates the sender by limiting the number of peers that are aware of the originating source of the message, basically. And Dandelion works in two phases, so stem and fluff phase. And the stem phase is basically when the message travels, let's say, in a private way. So each beacon node constructs a path, let's say a random path at first according to some parameters, and after, let's say, some hops, randomly the message is propagated by the normal, let's say, gossip SAP mechanism. So let's say this is a simplified model of how the message path looked previously. So we have validator client, which sends a, let's say, block proposal to the beacon node, and then the beacon node propagates the message via gossip SAP peer-to-peer protocol to other beacon nodes. And here, like, if there is an, let's say, attacker, they can, and they monitor the network traffic, they can, let's say, determine the validator's IP address. And then with Dandelion, this is how the network path would look like. So the validators first send message to the beacon nodes, like block proposal, and then the beacon nodes construct a path, and then they send the message as Dandelion message, so basically in a bit different format than the normal consensus layer message. And then that message is propagated first through a few beacon nodes, and then at the end it's propagated with the green lines down there as normal gossip sub message. And Dandelion works in the following way. So let's say the peer 0 sends a message to a subset. Here it's 1 or 2 peers because of redundancy, with a stem length of 3. So basically the maximum length the message will travel before it's revealed is 3. So it travels from peer 0 to peer 2, then peer 2 does the same, so it reduces the stem length first, and then forwards the message to peer 3, and then peer 3 does the same, and then peer 4 gossip subs the message, or basically forwards the message to all the peers. And with this approach we can harden the metadata analysis attacks. Yeah, so this is it, the fluff phase. But with this network only, not everything is solved, because this network is susceptible to spam, and also we need to ensure privacy, so only the validators can register to this network. And for this, we have been working on RLN, or applying RLN to this project. And RLN is basically ZK gadget implemented using ZK snarks, and it's especially useful for spam protection in anonymous environments. And basically it's a rate limiting mechanism which can be used for various other purposes. And it works by the users registering first to a membership Merkle tree, or being part of anonymity set, and the ZK proof proves basically that the user is part of this anonymity set, and also that they have constructed the Shamir secret sharing scheme properly. So basically we encode the identity secret of the user, from which the identity commitment is derived from, and that identity commitment is used as data to register into the membership Merkle tree. And also, like for the registration, it can be done in multiple ways. So it can be done on-chain and off-chain. On-chain, we can use a smart contract to do this. And depending on the application, it can have different requirements. So for this project specifically, the requirement is that the validators are active, but we cannot prove this on-chain because we cannot, let's say, verify BLS signatures on-chain. So we done some implementation where we have a smart contract, and we use that only for like a data availability. So the validators register through that smart contract, but they only pass like their signature, BLS signature, their identity commitment, and then like the other nodes in the network that are part of, let's say, this private network, they can verify if this data is correct or incorrect off-chain. And the rate limiting part works by the other nodes verifying it. So basically the validators first register to this network via the smart contracts, then the other nodes add the identity commitment in their membership Merkle tree if everything is valid. So let's say the validator is active, and then basically this validator can send messages, and these messages should include a ZK proof, so RLN ZK proof, and basically the entities just verify if the ZK proof is valid, and after that they should store additionally some metadata to check if basically the there were shares of, that's basically how the RLN works. So basically, if there are two different shares for the same epoch, then it is considered, the message is considered as spam, and the user can get slashed. And slashing is also app specific. In this case, it's we can construct the identity secret, and we can propagate to other, let's say, nodes that, okay, this validator just did spamming, and the other node should also remove this validator from the membership Merkle tree. Okay. Yeah, and the messages without ZK proofs are dismissed, and duplicates are also discarded. And also the slashing occurs at the private network level only. It's not on the consensus layer, so the validators can still be active validators on the consensus layer, but they cannot use this private network anymore. And also this needs more experimentation, so this is just still a proposal, let's say. And the conclusion of this implementation is that the private network improves the anonymity, and also this enables spam protection to the private network itself, and also overall to the whole network, because if we, let's say, if most of the validators use this network and spam is prevented here, then later on in the network spam is also prevented, and from this we can maybe, let's say, have different assumptions of some specifics on how the consensus layer works. And also, this is a kind of better solution than message idempotency, because of some, let's say, features such as proof of custody, where the validators would be, let's say, would be recommended for them to use their own beacon nodes, so they have, let's say, trusted beacon nodes, so they can verify the computation or the execution. And this is still in research and also development, but there are a few different things to consider. So the most important things is the network latency introduced. And there are multiple like latencies introduced here. The one is like for the message propagation through the private network, which is not so problematic, and also depends on the hops. So like those parameters needs to be, let's say, tweaked so that some optimal solution is found. But this is done through experimentation, and also there are other latencies, such as for the ZK proof creation, which is the let's say adds the most latency. So currently we have, let's say, 500 milliseconds of latency per zero knowledge proof creation, and also for proof verification, the time is pretty small, so it's 20 milliseconds for verification. Yeah, and I mentioned that the latency rules need to be respected, because like the rewards and penalties are tightly connected to that. So let's say we cannot do some wild stuff and introduce huge latencies, because it would make no sense, and validators would not use this solution. Okay, so this is a chart of the reward amounts based on the inclusion delay. So let's say if the attestation is included when it should be, then they get 100% of the rewards. If they're included in the next slot, then like their reward is cut by 50%, and so on. Okay. But there are some ways like to improve on this. Currently, like there is some buffer time we can use, and we need to experiment with that. And we should, let's say, optimistically not introduce a lot of latency, and this should be useful, but there are stuff we can improve, so we can use, let's say, different ZK proof system. So we have experimented with Hello 2, and that for proof creation time, the time is much better. And also we can tweak the number of hops in the private network, so find some optimal solution and experiment more with this. But yeah, the goal is, the overall goal is like to enable some kind of anonymity for the validators, because it should be important in the long run. So currently there were, let's say, no attacks or major attacks on this, but it's not, let's say, impossible. Okay, so that was it. I have added some resources here on this GitHub link if anyone is interested. But yeah, so this is it from me.
Thank you.
Thank you.
Thanks. Do we have any questions from the audience?
Hi. Would malicious actors would be able to create a new node and delay transactions throughout the network, or would they need to have actually 32 ETH to participate in this private network?
No, they need to be a valid validator, so they need to be active, and they have already staked. So this is for validators only, and this private network, so anyone can read the messages, but only the validators can, let's say, can propagate messages to this network.
This technology that you're working on, is it expected that the current clients for validating and the beacon chains, will they have to implement this, or would you have to run a separate software that does this message propagation? How do you expect that to go?
Yeah, I mean, this is still in experimentation phase, so if this works, we would like this to be more official, and obviously to have some specifications so that the validator's client maybe can implement someday. Also, additionally to this implementation, so we worked on an implementation which is a bit outside of the consensus layer without making any changes to the consensus layer, because there could be made some changes there, but it's very complicated because it would require, let's say, certain fields, and changing certain fields would require changing even more stuff, and yeah, it's a bit complicated.
I know in Tor and a bunch of other anonymity networks, there's some research about like number of nodes to de-anonymize other nodes. Have you guys analyzed that attack vector in this?
Yeah, we have analyzed that. So for Tor, onion routing does not make sense because it introduced so much latency. So we have looked at that kind of solutions. And also we have analyzed different approaches for implementing this with Dandelion, so using completely separate network, using the same connection. So there is some more experimentation to be done there, but basically the main idea is to create some kind of network that improves on the anonymity and makes harder for the validators' IP addresses to be exposed.
Any other question?
What do proofs actually contain? Because I probably missed that part.
All right. So the ZK proofs, like they prove that the one who is sending the proof, if it's valid, is part of anonymity set. It's part of a group without, let's say, revealing who they are, and also that they have generated their Shamir secret shares as they should. So we use Shamir's secrets sharing scheme for this part of slashing. So we encode the identity secret in the coefficient, in the first coefficient. And basically, with that scheme, if you have two shares, you can, let's say, regenerate the secret of the identity commitment of the user, basically.
Hi, and a question from attacker side. I'm not an attacker, but just interested. So, is it this metadata attack? Is it fully automated? Like, how long it takes? For example, if somebody wants to attack somebody else's validator, like, what are the steps? It's like you download software, run for 5 seconds, done?
No, I don't think it's that automated. So I think it requires like network analysis, and I'm actually like not sure like how that's done. How would you do that?
Anyone else?
Actually, hypothetically, can you still, like, if you're a participant of the network, can you still, like, kind of leak all the validator's IP?
Sorry?
If you're a bad actor in the network, can you still, like, kind of leak all the validator's IP, potentially?
No.
Okay.
I think that's it. Please give it up for Bagwe. So our next talk is going to be at 3 p.m. You guys are free to stay here, but make sure to visit our sponsor booth if you have not yet.
pudiese ser
Pero lo tengo que actualizar manual de eso, porque cuando se acabe... Sí, porque nos han baneado de la API de eso con los datos. Será un programa automático. Ya, pero es una chorrada, me da palo.
Ah, vale. ¿Eso lo tienes que hacer manual?
Sí, es decir, esta web tiene una sitio donde saca los datos. Yo les di el sitio, de ahí sacaba yo los datos, lo mandé. No sé, pero mira, ha cerrado el ataque al pie.
Sí, estoy un poco rayado.
¿Cómo que no?
El chaval ese que estaba con ellos en el
Ah, ¿no? El de... El de la pista.
Resulta que por algún motivo no saben cuál es su nombre de no lo sé. Es un poco extraño. No sé si que tiene a lo mejor algún tipo de colaboración con otros validadores y no lo sé. También se la que es súper injusto. Que no deberían de estar en la estaban en el Genesis o el también. Y... ponerme en cuenta, pero que de memoria no sabéis qué nombre tiene. O sea, que no están utilizando su nombre. Y luego me hacen una pregunta de cada cuánto puedes solicitarlo. Yo le he dicho, a ver, no te puedo decir la regla, pero sí que te puedo decir, no, no, he dicho, pero sí que te puedo decir que para que no perder el tiempo, puedes reclamar hoy, puedes reclamar mañana, y yo voy a decir. No, pero diles eso, diles que desde 3 cuentas de Twitter. Pero no te he dicho. No les digo. Hoy sí, pero mañana sí.
No se elevado a 0, claro, no se elevado a 1. Vale, sí. No, no se elevado a 1.
Es muy raro. Se elevado a 1,
Sí.
Yo creo que estas columnas no soportan presión.
No sé si habéis visto la que ha caído en Chipside, en España. Ah, no he visto mucho. Están todos quemadísimos con la rigor. Porque la están liando, los de Chipside la están liando pardísimo. Con el tema de la rigor. Porque todas las semanas, todas hay fallos. Todas. Entonces, están metiendo ahí un food que flipa y... está viendo mucha gente quejándose, gente diciendo pues me voy a osmosis, que eso me lo hacen mejor la rival, no sé qué. Está viendo una cantidad de coño, 50 mensajes esta mañana cuando se ve el grupo es súper callado y están súper descontentos y yo creo que eso tengo que transmitir al equipo. Aún así, eso que te iba a decir, aún así han hecho ya un comunicado que espero que María lo vea y lo transmita con todo antes.
Pues sí que deberíamos decirlo, porque por lo menos para que a nosotros nos excuse de que, oye, de que si el grupo no tira para adelante, no nos da gusto.
Ya, pero es que está hecho...
Está guay que son bloques fuera, ¿sabes? Claro. Aún no os habéis pillado de... los ingenieros han... Bueno, mira, son bloques.
Anda. Vale. No. A ver. No haya caído.
¿Ves? Estaban...
Claro, es que son bloques dentro de bloques. Habéis hecho un grupo de sí. Y no
siempre, tío.
Es software abajo y es en media hora. Así que sí podemos ir por abajo, me está aquí quieto.
Porque esta gente que me lo tenemos en los eventos solo está en grupos de eventos. No está en tipo roster y cosas así.
Yo creo que hay una separación entre los constructores. Más que los constructores están tan centrados en construir que no se meten a... Pero tú estás enfocado en los proyectos que se pueden... ¿Por qué? Porque no mira... Igual con se hacen los mismos eventos, pero eso de grupos generalistas... A ver, a veces me gusta. Y de la y nosotros, o sea, hay un mundo ahí fuera.
El mundo de Ethereum, que es de lo que va, ¿no? Y no está...
Yo creo que es al contrario. La comunidad es un plan, ¿sabes? Si tú eres algo dentro de
la bota de polvo de todo.
Claro, es la comunidad de Iván.
Me están hablando con alguien, pero no lo veo.
Bueno, ¿qué hacemos, chicos? Movemos a ver qué vemos por ahí. Aquí no hay... Y arriba y luego para abajo. Oye, ¿puedo repartir camisetas? Joder, yo lo siento, de verdad, para aprovecharme de vosotros. Uy. Eso también es la que voy.
Like 3 to 5 minutes.
All right. Welcome back, everyone. Welcome back. So I don't know if you've heard about our hackathon on Thursday. If you have not, make sure to check it out on our website. There's 10,000 USDC in prizes. Like first place is 5,000. And like if you have any staking related projects idea, you get a chance to win those. And there's still plenty of room for new projects to register. So make sure to check out our website. All right, that being said, we will go to our next speakers. For this talk, we have two Ethereum, two ETH Staker core members. The first one being Colfax. Colfax is also the founder of Gitpo app, right? And maybe you could go ahead with the next one.
And the second speaker is also an MC at this event. His name is Remy Roy, or Remy Wah, right here. Yours truly. Remy is also a core member at the ETH Staker crew. He's been instrumental in helping put on this event, and he does some really awesome open source work. So what he's talking about, the hackathon on Thursday, highly encourage you guys to come out, even if you just want to test out some tools or share some ideas. It's going to be fun. And GitPoApp will be distributing PoApps to everybody who participates, so it'll be fun.
Make sure to join.
Yes.
All right, let's get started. So our talk is going to be about choosing a staking option, and this one is for new stakers. So our perspective here is like your barber asks you about staking, what you tell them, right? So let's go ahead. So there's many different options for people to stake. And so it can be daunting to find out which option you should be choosing. And so like the main options that are available right now, we have 3 buckets. We have like solo home staking, we have staking as a service, and we have pool staking and custodial staking. And so I don't know if you've seen this website, Ethereum.org recently added this very nice resources. You should definitely check it out. It has a bunch of documentation and like good insight into which option you should be choosing to use as your staking option. If we start with the solo home staking, it's like just staking at home with your own machine. Staking as a service is using a third-party service to stake. Pool staking is using often like a fractional amount of the needed ETH to stake, and then centralized exchanges are like you just give your ETH to someone else who does the job for you.
So depending on what option you choose, there's different ways that centralization can enter into the Ethereum network. And the whole reason why we're all here is to keep the network as robust and decentralized as possible. And so what we want to do here today, as Remy was saying, is just give you like a very high level overview of like the questions that you should be asking yourself when you're thinking about staking and the implications that will come out of like what resulting staking option you choose. A few different ways that centralization can actually enter into the Ethereum network are via miners and node operator centralization. So think about it this way. If we all gave all of our ETH to one person and that person staked all of the ETH, that's pretty centralized. So that's on that level. Another one is software client. So there are 4 different clients, or really 5, and there's a couple more being developed for proof of stake. And if everybody uses the same client, again, that's centralization. So if there's an issue with that client, then there's going to be a problem in the whole network. Another way is hardware. So imagine we're all running our validators on MacBooks, and there's like a problem with MacBooks, then the entire network goes down. Cloud provider, geography, same story. So what we really want to do is be choosing staking options that are making the network as decentralized as possible. You can see here when I was talking about centralization when it comes to node operators, there are some individual node operators, some like exchanges and pools that have quite a lot of the market share. And not everybody can stake at home, but there's a lot of great tooling, and we'll talk a little bit more about it. And depending on where you are and what you have the bandwidth to sort of support, there are some options that will actually help the decentralization of the network a little bit more than others. So there's a few questions that you should ask yourself when you're considering to stake. One of which is, how much ETH do you have that you want to stake? Another one is, are you able to run a node at home? And the third question is how technical are you? And like really how willing are you to do a little bit of maintenance? And so we're going to talk in a little bit more detail about how you answer these questions and then the resulting implications of like what you're able to do for staking and then how that may or may not contribute to centralization of the network.
So 32 is the magic number here. So I don't know if you guys know, you need 32 ETH, which can be a large sum for some, before you can start having your own validator on the Ethereum beacon chain. And so maybe you don't, maybe you do. We'll go through all the options if you do or if you don't.
Yep.
So the next question is like, are you able to run a node at home? And for some people, like reliable internet is not possible, depending on your ISP or your country in which you leave. Some countries and places don't have like good enough internet for you to run at home, so that's like a cross there. Electricity too. Electricity can be easier to manage. A small computer with a large hard drive. So this is like an initial investment that you need, and some kind of monthly maintenance that you'll have to do over time to manage your node.
The next one is how technical are you? So we're in the midst of being able to have a lot more tooling around staking, installation, and automated infrastructure. Right now, it still takes a little bit of technical prowess, and then some tools actually do assist you with all that. But if this line makes sense to you, then you definitely can run a node. If it doesn't make sense to you and you want to either learn how to use a command line, it's really not that difficult. It may be a little foreign, but you can definitely learn. And there's also a lot of great tooling that's being developed, and some that's actually really available on mainnet that's recognized on the ethereum.org staking page that can allow you to set up your staking validator at home without having to do too much stuff too technically.
And once you start looking at all of the options and those questions, the first question you should probably ask yourself is, do you have 32 ETH? Because that will influence the most options that are available for you. And so if the answer is yes, the next question you should be probably asking yourself is, can you run a node at home? And is that feasible? And like, can you do your own maintenance? If you still answer yes, you should be asking yourself, are you technical? And if you still answer yes there, and the result for you will be the golden standard, which is solo home staking.
Yep, and the answer of are you technical is yes, question mark, because you don't need to be too technical. You at least just need to be adventurous enough to want to try it out. And being comfortable running it with some assisted tooling, so you will have to do some maintenance, but you don't need to be super technical to do it. And again, this is an extremely high level. There's a lot of nuance and sub options like within each of these, but the objective here is like if you were to explain to your barber what they should be thinking about, these are kind of like the broad buckets that you should be thinking about.
So the important variables that you have to think about, whether you end up in one of these buckets, they will have like implication that you'll have to think about, right? So, and as you grow through these options, you'll have to think about even more variables. So the first option is the solo home staking, and when you get there, you have to kind of think about like, am I using a supermajority client or not, and how easy is it going to be to use my setup at home?
Yep. And this goes back to some of the original parameters we were talking about. So when you're solo staking, you are not contributing to centralization on like the node operator front because you're adding a new node operator. There are many hardware options, so that's, again, keeping this super high level. You don't need to think too hard about that. But the primary things that we're thinking about for this is client diversity and ease of use.
And as you go down to these other options, staking as a service, you have to start thinking about trust, right? So are you going to have to be trusting a third party or not? And there are like different options into that, but you still have to think about client diversity and ease of use as you use your staking service. And then once you get down to the different pooled and custodial staking options, you have to add decentralization as another variable that you have to think about.
And that's, again, getting back to the concept of like a single node operator running a lot of the stake within the network. So back to this decision tree, this kind of gives you a little bit more color on when you end up in one of these buckets, even within each bucket, if you ask yourself those questions based on the primary categories, you can kind of find a good option within each bucket that is better for the network. Obviously, the golden standard is solo home staking, but even within like the pooled staking options, some options are more decentralized than others. So we encourage you to, when you're looking at it, to ask those questions and find the best option for the network. So Remy.
Go ahead.
If I have 5 ETH and I'm not technical and I travel a lot, what do you recommend I do?
So that would scrap home solo staking already. So your options would be either, I think the only option would be pool and custodial staking, unfortunately.
How about if I have 33 ETH and I'm not technical,
So-
but I can run a node at home?
Yeah, so this one is a little more murky. Technically, your options would be staking as a service or the pool and centralized services. But if you want to explore a little more, if you don't mind getting your hands dirty, or if you don't mind using a third-party tools, there's a lot of these different options where you can still stake from home, which are very interesting to explore. And there's various ways to explore them. Like you can stake on a test net without using any real value first, and then you'll be able to see how it goes with your own home setup.
Amazing. And again, I encourage you guys to check out the ethereum.org page because it breaks down a lot of the different tools that are available and the different sort of evaluation criteria. One last example. So Remy, I have 0.005 ETH and I'm technical and I can run a node at home. How can I
So
stake?
if you're in that situation, unfortunately, your only options are going to be to use a pool service or a custodial service.
And stack more ETH.
And stack more from there.
Makes sense. Cool. Again, I try not to overshow, but it's a really amazing page. Ethereum.org/en/staking. It's also translated into many different languages, and it's really just a really great collection of different information about staking and how to set up your node. So I encourage you to take a look at that.
You should check that out.
And one more note, again, on the hackathon. We're having a hackathon Thursday to develop even more tools around making staking easier and more accessible for people. And so it starts at 9 a.m., but you don't need to be there right at 9. I think project registrations closes at...
At
or at 9?
At 12.
At 12.
Yeah.
Okay, cool. Sounds good. And you don't need to develop an entire whole project on on Thursday. We just want to seed some ideas and sort of get some basic features developed that hopefully will turn into more full-fledged applications afterwards.
And we'll have people supporting you, so if you want to start your project, you don't even know exactly where to go through. We'll have support, mentors, and a nice team of judges to check your projects.
And you might be wondering, after you start your project at the hackathon, how are you going to make this a sustainable project for you to work on? Well, shortly after this conference, ETH Stakers partnering with CLR Fund to run a quadratic funding campaign for the staking UX and making staking easier. So we haven't announced it officially yet. The announcement's coming, I think, on the 22nd, but hot alpha leak here. Keep an eye on the ETH Staker Twitter, and we'll be announcing a lot more information there soon, and you'll be able to come up with your project ideas and sort of apply to be a grant recipient. And a lot of people are going to donate. It's going to be fun, and it's going to be a cool way to encourage a lot of developers to get into building open source software. So also, if you're a developer and you're wondering how to get involved in Ethereum, how I really got involved with Ethereum originally was joining the eStaker crew and just working on some open source tooling. And it's been a lot of fun over the last year and a half, and I've gotten to know a lot of great people. So it's a great place to start.
There's a lot of opportunities.
Yep. Cool. Well, that's it for us today. Thank you for listening to our talk. This is also the eStaker website if you want to come check it out, and we'll take questions now.
Thanks.
Just a quick question. If you don't have 32 ETH, does it make sense for me to just go gather up a bunch of my buddies and create my own node, or would it make more sense to just take advantage of the pooled staking resources?
That's a great question. I would recommend, if you have people that you trust and you can find enough, like over 32 ETH, solo staking really is the golden standard. So I encourage you to do that. If you can't, then I would encourage you to look at pooled staking and evaluate the pools based on those criteria. But again, make sure you trust the people you're going to be. One person is going to have to be in charge of all the ETH, so I don't want to make sure you don't get rugged. There was a question right up here.
There.
Let's say my internet and electricity is generally robust, but there's it goes down. What would be the risk there?
So that's a really good question. There are two ways that you can lose ETH as a validator. One of which is like due to negligence in a sense. So it's just like sort of passive, like if your internet goes out, if your electricity goes out. And the penalty for that is actually quite small. Because we know that like people's powers go out and things like that. Like the network is built to be robust against that. The other way is via slashing. So that's if you do something actively malicious, and that penalty is quite high. But if you're not being malicious, there's a low likelihood of being slashed. So the general rule of thumb I've heard is if your power is going to be out for less than 2 weeks, then you're fine. And you just sort of, you lose a little bit of ease. So you basically lose the same amount as you would have earned by being online. But if you're going to be out just like in small spurts, like I miss an attestation every now and then, and it's really okay for the network. But if you're planning on being offline for like more than 2 weeks, then you should set up either like a redundant setup, or you should maybe temporarily set something up in the cloud if like you're moving or something like that. But yeah, I wouldn't stress like over a few missed attestations.
And a lot of people are worried, or like they're scared about having their node go down for a few hours, or like even for maintenance. And what I usually say to them is like the downtime penalties are very tolerable under normal circumstance. So you should be good, like even like a few hours or even like a few days per month. It's still interesting to stake on Ethereum.
On that note, kind of segueing slightly into monitoring, Remy has actually made a bunch of amazing monitoring resources and guides and videos on YouTube, and they're on the ETH Staker channel, most of them, I think.
I think they are, yeah.
So I would encourage you to take a look at that if you want to know, like, oh, how am I going to know if my node's down? Remy's made a lot of awesome videos, and then Beacon Chain, the website, also can help you track, and we'll send you alerts when something goes on.
Hi, let's say I want a node, and I don't know how to make a secure network. Also, how to secure my network if I want to run a node.
That's a good question. I guess we don't have some good tools to help you with that. I guess we might have some references to give to you to help you secure your network, but you might have to learn a little about that if you want to stake from home.
Yeah, and I've seen some good guides for like basic steps that you could take to secure your network. I can't think of a specific one off the top, but I encourage you to go to the ETHStaker Discord. That's discord.io/ETHStaker, and just ask there, and we can send you like a list of resources for that.
On that note, too, there was one by Mentor, I think, that was recently put up on YouTube.
Yes, there was.
Which is excellent for home security. The Staking Launchpad also has a checklist on there that can help. It's not perfect, but it has a lot of things you should check over before you go to mainnet. One thing I'm now forgetting what I wanted to mention.
While he remembers, Paul is one of the creators of the Ethereum.org staking page, so big kudos to him for putting that together.
I guess I just want to broadly bring up, like, where would people go if this is all confusing and they don't know? Like, if there's people to talk to, is there like a Discord anywhere?
There is a Discord. The ETHStaker Discord is a great place to go. Also, the Ethereum.org Discord is a great place to go to just ask any questions you have about Ethereum. I remember when I was learning this stuff, I basically just popped on and asked some questions. Everyone was super friendly. The ETHStaker ethos is being welcoming first and knowledgeable second, which is kind of funny for an education community, but it's actually like very true. Like everybody's just so welcoming and wants to make sure you feel welcome before people throw information and resources at you. So I encourage you just to reach out.
The only other thing I wanted to mention, I'll just reiterate, because this is often misunderstood, is going offline does not get you slashed. Like, it's not the same. Slashing is a significantly different penalty for malicious behavior. There's specific types of votes that can cause this. It's not going to happen by accident. Just run your keys on one machine and stick with a minority client, basically, and you'll be all right.
I see a few more questions. I think I'll go here first.
How can we have a multi-sig contract kind of staking? Like, for example, if I and my friend both want to stake and we want to do it via multi-sig contract, can we do this staking?
Interesting. I've never set up a multi-sig contract for staking. I wonder, Remy, are you familiar with anybody doing that?
I'm not too familiar, but I guess you could have like a multi-sig contract that does a deposit, and then when you do the withdrawal eventually, it could go to that contract as well, and then eventually you guys could figure out how to split it.
Yeah, so go ahead.
How do you manage that in this case?
So he was just asking about, you still have the deposit data and the validator signing key. So presumably if you and some friends put together like a multi-sig wallet and made one deposit, you would just have one validator key and one person would have to run that on their system. People are working on like key sharding, and there's a few other talks here talking about how to shard keys, and you could run it across multiple machines. But if you had the withdrawal address send the ETH eventually to another multi-sig wallet, the person holding the key would not be able to take the money. Presumably, if you didn't trust them, they would only be able to exit your validator and or possibly get you slashed. But again, that's only if they like really were doing something highly malicious. So I guess presumably, yeah, setting up deposit from a multi-sig wallet, like a Gnosis Save or something, and then having the withdrawal back to there could be a reasonable strategy.
I think I saw a few more questions.
But do your own research and testing.
When does a validator voluntary exit? When does a validator is forced to exit? Like there is a mechanism like after 2 weeks, I think he's forced to exit, right?
No,
Voluntary
so right
exit.
now withdrawals are not enabled, and so nobody's like exiting their validator. And after the merge, like shortly after the merge, like probably a few months later, withdrawals will eventually be enabled. And I think there is a cooldown period for how long it takes for your validator to be exited, but I can't remember off the top of my head.
Can I turn the node on and off occasionally without any serious consequences?
Yes, in fact, you should to like install system updates and things like that. And you'll probably miss a couple attestations, but it's really not a big penalty, so I wouldn't worry about that. It's very much built into the protocol, the ability to like do maintenance and like be offline every now and then.
Hey, are there any good ways to offset the centralization that using a pooled or custodial service like running a node or anything else like that?
Sorry, so you're asking like for custodials, if you're doing like...
Yeah, so if you don't have 32 ETH but you want to stake, obviously anything other than solo home staking adds some sort of centralization by some sort of way. Are there any recommendations you would have to try and offset that a little bit?
So I would recommend if you are going to go with a pooled staking option, you should look into how decentralized that pool is. So like how many actual validators or how many node operators they have running validators. And there are some decentralized staking pool options as well, which are more decentralized. So even though you are staking on a pool, the way that the pool is orchestrated is like through a smart contract, kind of like what you're talking about, but it's like at a massive scale. So I encourage you when you're looking at pools, look into how centralized they are and try and pick one that's more decentralized. And then also ask questions about the pool, like are they using, going back to our few questions, the questions build on one another. So when you're looking at a pool, that doesn't mean you can ignore client diversity. You won't be able to choose what client they run, but like you're a customer of the pool, and if they're not using clients that are decentralizing the network, like you as a customer can post on Twitter, I guess, or call up support and encourage them to think hard about client diversity and running minority clients. So,
Any other question? I think that's it.
awesome. Well, thank you guys.
Thank you, everyone.
We'll be around if you have any more questions.
Good talk. Yeah. I think we did a good amount of plug-in for the.
I think we did. Yeah.
For the hackathon.
Yeah, I think so.
shout out.
Hello everyone. 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 Is it working? Maybe I. Hello everyone. Is it not working? Hello everyone. Hello everyone. There you go. Hello everyone. Welcome back. Welcome back everyone. Please have a seat if you wanna enjoy this next speaker. So our next speaker is the Ethereum ecosystem lead at Block Daemon. Please give a good round of applause for Freddie.
Thanks, guys. There we go. Oh, that's the end. I'm going to start with the end right away. Here we go. Right. I'm here to talk about client diversity, and in particular, I did some financial risk scenario modeling because I work with Block Daemon. We're a large staking provider, so I wanted to give, sort of the economic side of things for this client diversity issue. I guess you're all aware of it. So it's sort of a moral and network obligation that you have, but still for our engineering department and stuff, if they have to run multiple nodes, it adds complexity, it adds risk, in the management of things. So I wanted to counterweigh that in showing, what the economic consequences of these failures could be, right? And that's what I want to share with you. So as you might know, the Prism supermajority is gone. Yay! So I got a little meme there. It's the only one that I have, I promise. But are all our problems solved now? And as you might have guessed, sorry, we're not done yet. Actually, there's a good deal of work ahead of us, I think. I was actually amazed that, how bad it is. I'm not trying to be too, negative about this, but yeah. So Freddie, Ethereum ecosystem lead at Block Daemon. Previously, I was the co-founder of AnyBlock, and we got acquired last year by Block Daemon. And Block Daemon, I just gave you some numbers. We're big. We're all about infrastructure and nodes. Our customers are institutional organizations that need nodes or that want to stake with us. We're on 50 protocols, 11 billion, so yeah, it's big, right? Right, so I'm going to start with the current state of the client diversity. Next one is the risk models that I've done, and then I have some suggestion on what we could do next. So let's get straight into it. We do have progress, which is great, but we need to work towards it. So these are the numbers as of yesterday from clientdiversity.org, which is like the greatest resource. You might have noticed if you're following this in the last couple of weeks, about 7% switched from Prism, which is why the supermajority sort of was eliminated, and everybody was, yeah, that's great, and it is great. It is like a major achievement, actually. But what I noticed as well is that it pretty much all switched from Prism to Lighthouse. So Lighthouse percentage has risen basically in the same thing, and Teku and Nimbus stayed pretty much unchanged. So if this trend would continue, then yes, Prism majority would go down, which is good, but basically we would be stuck with Prism having above 50% of the network and Lighthouse being above 33%. And like I said, I didn't do probabilities. Like I deliberately left out in my models like how likely are these scenarios, which obviously if you want to quantify risk, that's what you have to do. But honestly, that's above my pay grade. I don't know. And everybody that I asked was like, we don't know either. It's unlikely. But someone said, if you have the timeline of infinity, then probability will always be 1. So that's not really something that you can work with, but I guess it's also the truth. So anyway, so what I'm really saying, I think this might not be much better to have one above 50 and one about 33, because then we have two problematic scenarios, sort of, rather than only one. So I don't know, something we can discuss. So for those of you that don't know why there are these problems with those thresholds, I'm just going to quickly recap that. So if there's one client that has more than 33% of the network, then if that client fails, so all of the nodes that run this client fail at the same time, then the chain cannot finalize, which basically means that exchanges wouldn't process your transactions or your withdrawals and whatnot. So wallets, anything that wants to wait for finalized state. So that's bad. And also then the first mechanism for Ethereum to heal itself, the inactivity leak, will kick in and will punish the ones that are offline. But what many people don't realize, it also affects the people that are online, because they don't get any rewards why the inactivity leak is happening. So I actually thought this is sort of unfair, but now, having thought a little bit more about it, I think it's actually great, because it makes this really a community problem. Like, everybody has to work towards this goal, because everybody is going to suffer. The ones that run the majority client, or the client that fails, will be more affected, of course, but also the others do have a stake literally in this. So there is going to be a big loss of fund, and we're going to look at the numbers in the second part. It gets even worse if you get over 50%, because then you would have sort of a split in the network. So neither of those networks could finalize, actually. So they would both start their inactivity leaks and try to leak out the ones that are inactive or in the wrong chain or the wrong setup, whatnot. I mean, there's obviously multiple scenarios of what could happen, and maybe they fail completely and don't have their own chain, but theoretically we'd end up in this scenario where we'd have two chains that are running towards finalization again, and we definitely want to avoid one chain or both chain finalizing on different states, right? Because then we cannot put them together anymore. And we would have about 3 to 4 weeks to handle the situation, which seems doable. But remember, if we're going to say, okay, one chain is the wrong chain and the other is the correct chain, then half of the people would lose a great amount of funds, right? So that, again, is hurting a lot. So this is a great loss of funds. And it really gets catastrophic if we're having the supermajority that everybody was worried about with Prism, because then the faulty chain potentially could finalize. So we have a faulty chain, which is the history of Ethereum, the official history. And then you basically have two options. You could sort of accept this faulty state and then build on top of it and basically have the other clients incorporate the problem, which is really not nice and also very unfair to the stakers. So you got to think about financial consequences again. Or you would fix the supermajority client that has the problem and then bring it back towards the other. But since it's finalized, then everybody in that client would get slashed, or they would have to exit the chain, which would take months because it's a lot of nodes. And then they would have, again, dire consequences. Catastrophic, you can always say that. And this is only, I'm only talking about the consequences for the validators, but obviously the network as a whole, the ecosystem, the ETH price, there's going to be all sorts of, collateral damage, basically, that it will affect everybody. Right, let's go into the financial risk scenario models. And the reason why I approached it that way, I could have given you the facts as it is now or as I see it now, but I wanted to give you a tool, if you're in the same situation like me, to actually model what your setup is like. My question was, okay, we are active as Blockdaemon, we're working actively to increase our diversity in the nodes, but what's our target goal? Are we 25, 25, 25, 25, or are we 50, 50 for two clients, or what's the factors? And obviously the engineering departments, they have a say in that, but I wanted to come from the financial aspect because that's what I know about, and say, okay, what can I gather from this information to find the optimal setup? So yeah, just to grab everybody's attention again, now we're getting really into the things but it also has a more subtle meaning, basically. I'm talking about the nuclear options here, right? There's a lot of other things that I'm not looking into or not addressing here, and happy to chat about this afterwards or something. I'm not talking about your everyday like car crash. Okay, you got a little, dent in your door and your car or something, and you can get insurance and get it fixed or whatnot. So if your client is offline for like a long weekend because you've gone camping and your node failed or something, that's not what I'm looking at, right? I'm only looking at large scale stuff. So nuclear war, maybe conventional war, maybe, really bad stuff, but as recent weeks, we've seen it might not be as improbable as we all thought. Right, so I'm going to switch here. Is that showing? Yeah, okay. Great, so this is the spreadsheet that I have, and I'm just going to walk you through here. So the yellow parts are the stuff that you can put your stuff in. So I updated the numbers yesterday, so we have about 350,000 nodes currently. This is the number of the nodes that you have. I just put 100, so it's easy to do the math. Here you can put in the ETH price, so you get the quantified numbers. And then I have two sets of scenarios. On the left side here, and it's the same scenarios on both sides. On the left side here, we have inactivity bugs. So whatever the problem, the client is not active, cannot attest to blocks, right? That's the more likely scenario. The even less likely scenarios are the slashable bugs. So whatever that client produces will be slashable. To my understanding, that's highly unlikely, but still. We got to think about those bad things, I guess. You could, if you don't like the nuclear war thing, maybe it's an asteroid hitting Earth or, whatever. It is unlikely, but it can happen, and it happened before. So, and then the other things here, it's really straightforward. You just put in the client distribution as it is on the whole network level, and it'll actually give you a rundown so you can have the absolute numbers. I find that, sort of more tangible maybe than percentages. And you can put in your combination of clients that you're using, right? So I started with the worst case scenario, basically, so the current network configuration, and that the company is sitting at 100% Prism. And then I thought, okay, if Prism fails, but the company has switched to, let's say, Lighthouse and Nimbus, for example, in a 50-50 scenario, that would be the second one. Then I have one which is called Ideal World, so everything in the network is divided 25%, and the company itself also divided themselves up in 25%. Then I thought, okay, what if the minority client fails, right? I mean, it doesn't have to be Prism that fails, right? It could be any one of those. So what happens then? And also, again, here I have a 50-50 combination of nodes on, different clients. Doesn't matter much. And then I have a special scenario if you're staking with a less than 10% node or client software, sorry. And then down here is the math, and we can dive deeper into that if you're interested. But for now, I just look at the outcome. So basically here, in these 3 lines here, you have the network losses accumulating here in ETH and in percentage of total network staked. And down here, which is what my original goal was, this is the punishment of the company. And again, I put it here, I didn't model like missed rewards and the sort of punishment that everybody has to take and whatnot. Those are comparatively low compared to these options. But yeah, let's have a look at that. So let's start with the inactivity one on Prism. So 60% have a problem which actually did exist in the test nets. And you'll see the network will lose about 1.5% of the ETH, which is a lot. Like I think 500 million, más o menos. So it's a lot. I'm assuming 3 days of downtime and fixing and until everybody is up and running again. I think in Medela it took us 5 days to really be up to speed again. So I figured 3 days would be fair. And in that setup, so if the company is running only Prism, you'd lose like, $200,000 right there. So that's not cool. That's why I put it yellow. That's sort of not so good. But if you move on to the right side, so if you switch to a minority client, then it's all green. Like the company punishments are effectively 0. So that's great. Like whatever other scenario we have, that is not above the 33% threshold that you are staking on, then you're good. So the network might still lose something if it's still the majority client, obviously the same punishment as on the left side, but it's you're good. And now move on to the even more catastrophic and more unlikely slashable problem side. So here, this is 60%. 60% of all staked ETH would be gone. So that, I think, and that's why this nuclear war thing came, like this is where civilization fails. This is where probably there's going to be some way of fixing that. We probably won't let it run its course just by itself because it's just too big of a thing, right? But yeah, if you're on the majority client, you lose 100% of your funds. So with 100 nodes, that's like 10 million. That's your maximum damage that you can have. And the reason I didn't go specifically into that, besides the inactivity leak penalty, which is kicking in when 1/3 of the network goes offline at any given time, we have the correlation penalty for slashing. And what that means that if there's several validators that get slashed in the time when you get slashed, your penalty increases because the network basically assumes this is an attack rather than this is an individual mishap. Basically, you're migrating keys or whatnot where it would be a reason for you individually to fail. But and that would kick in, and that's exponential sort of, and that's why it goes up to 32 ETH straight away pretty much if you have that kind of majority doing slashable offenses at the same time. So that's bad. Again, looking at the second scenario, so the company has switched to some minority clients. Again, this is 0. But as you can see, it's still yellow because if the Ethereum ecosystem is going to go down, you're going to be affected, right? That is still, you're going to suffer a lot. So that's why I said this is not, everything is good, but it's still bad, but you're actually not taking a direct hit on that. Now, what I found interesting is in this ideal world scenario, so the network is divided up equally and you're also divided up equally. So basically, can it be any better? If the client would fail, or any one of those clients, basically it doesn't matter at that point which one is failing because they're all 25%, it's still pretty catastrophic because there's still 20% approximately of the staked ETH that gets lost, which is, again, I think that's on 5 billion, sort of. So that's, again, massive loss of capital. And you, again, as a affected one, you're basically, and whatever, again, thinking about the probabilities, because you now have 4 clients, you're always going to be affected. Whatever 4 of those are affected, you're going to be affected as well, and you're also going to lose 20% of your stake. So I thought this scenario would look better, basically, because it feels to me like, okay, we've done everything we could, right. And then basically if you're a minority client failure, then it's pretty much, depending obviously on the percentage that fails, you can see it here, I played it with the 5% or with the 26% that fails, then the loss of ETH on the network level sort of corresponds roughly to the percentage, and depending on your allocation, your penalties are there. So there's no green solution in this one, right? So this is really bad. But as I said, this is very unlikely, so not all is lost. But it's like nuclear war, very unlikely, but if it happens, very bad. So, and the good thing is, and I'm not going to go into details, if you want, we can have some questions afterwards. Now you can model your own scenario, just copy and paste the column and, play around with it, that's what it's for. I have shared this on Twitter and I will share this and the slides afterwards on my Twitter again. So if you want to play around with it, you're welcome to. Now let's switch back to the slideshow. Right, so here it just explained what I just walked you through, so I'm going to skip that. And basically, the key takeaways: get a minority client. If you have your nodes on a minority client less than 33%, you don't have to worry about inactivity at all. That's great. Yes, you will be punished sort of as, the others are taking the hit. You're not going to get your rewards, but it's going to be sort of like 3 days. It's not going to be too bad. So then you don't have to, like a full class of problems, you're fine. So that's the great news. The bad news is what I said on the right side, even in the ideal world, if client level leads to slashing, everybody is screwed. Yeah, and then there's also links to real world cases where it happens during the test nets. It did happen. So, and that's also why I'm super curious to learn here in Amsterdam what's people take on the timeline of the merge. Is it going to be, rescheduled, or it was never really scheduled, but so is it going to be happening June, July, or is it going to be more like September? So I could see reasoning why this is still too exciting to do the real thing, right? But then again, does it get better over time? You never know. So, but coming to me, to the most important part of the talk, right? I try to, get some things, actionable insights, basically. And basically, we could leverage what we have. Number one, client diversity is important, but I call it like a first world problem. Because really, many other chains have only one client. If it fails, the chain stops, full stop. It's, in some sense, it makes it easier, like, Solana's halting again or whatever. Nobody gets punished because it just stops, and, everybody is on the same side of things, so that feels like an easier solution or easier setup. But obviously, the ultimate goal is to keep the chain running, right? And with our 4 or more, clients, we are in a prime position to have that. That's great to have. So let's, just celebrate that a little bit while still talking about the issues that come with it. And I sort of made 2 classifications. So if you're an institutional serving staking provider, then if you switch away from Prism because you got scared by the numbers that I showed you, then don't switch to Lighthouse. Or you might not want to switch to Lighthouse because then they might go over 33% and you're basically coming into other sorts of problems. Actually, and this is why I have this scenario smaller than 10%. So if you'd switch to Nimbus or Teku, you could actually get insurance for this client failure from Nexus Mutual. They're just about ready to launch a new product about staking insurance. And obviously, they can't cover a major outage like I showed before. But if you're less than 10% of your client, you would get part of it insured, which is great, I think. And if you're setting up new operations, because it's a little bit more involved, you can think about multi-client setups like Vouch from Attestin, which I think is a sponsor here, because that will give you a number of advantages that I don't go into here, but that would basically be ideal for you, because whatever client fails, you'd always have another one that is active and would attest on your behalf. So you could completely eliminate the risk. Obviously, you're introducing a new client, so there's also some complexities, but on a high level, it will greatly reduce your risk. And if you're an individual, like a crypto native staker, consider the small clients if you're doing it yourself at home. Like, don't be afraid. Like, definitely this should not scare you at all. Like, this is for institutional, great stuff about, nuclear options. Just go for it. It's easier than you think. There's great options. Slashing is practically impossible if you only run a single node. Like, all the slashing events that happened in the past happened because of hot failovers and client migrations and stuff, things that you would normally not do at home. Because if you're only inactive for a limited time, it's not really that bad. So you wouldn't at home do these fancy setups. And also we got great liquid staking providers, so consider them because they work greatly in the past to diversifying the client set. And I think it's up to everyone's guess. I didn't, dig deeper into it, where this switch from Prism to Lighthouse came from, but I think they're doing their part for sure. So basically, then you don't have to worry about it, and they're doing that job for you. One more thing, we do have that same problem on the execution client level, right? Because Geth has about 80% of the execution clients. So that is bad. Now you could say, ooh, this is another, nuclear explosion. I don't think it's that bad. Why it is not so dramatic? These are battle-tested clients for longer. There's likely no slashing scenario at all because they're execution and not consensus layer, obviously. And because people will use several execution layer and consensus layer clients combinations, that will reduce the failure risk probably as well. But that combination of clients that are unique with after the merge, that is brand new, so it's likely to have it. And actually at the kill and testnet merge, there was a problem where Prism was proposing bad blocks in some combinations of things, so that would be something. But if Geth would have a fundamental problem, then the inactivity leak scenario of before would again kick in. So again, this might not be priority 1, but it's definitely priority 2 to also diversify across that number, which just made my life a lot more complicated because I don't have to convince the engineering part about the consensus client, but also about the execution clients and think about what possible combinations would work best. So, yeah. But I want to end on a positive note, basically. We have a great community that's been working for this. I named a few on crypto Twitter. Like I said, the liquid staking providers doing their part. There's great websites where you can follow this developments here, and there's great resources where I learned a ton and where I just absolutely go to every time I wonder about what is rewards or punishments or whatnot, like upgrading Ethereum or the annotated spec, everything really awesome. So I wanted to share that with you guys as well. And now I'm happy to take any questions. And like I said, there's my CryptoCrack Twitter handle. I'm going to post the slides and the link to the model again after this.
Do we have any questions? If no one has a question, there you go.
So do you have an opinion about why institutional providers don't want to use Teku, Bezu, Nimbus, or the ones that have sort of sub 5% share?
I think it's like grown. Like I think Prism was, and I don't nail me on it, but I think they were sort of the first to market or first ready, best documentation, easy to use, whatnot. So once you got started on one thing, if you migrated, I know that our engineers are worried about slashing when you migrate clients, so we're trying to combine migrating from different data centers as well and do it all in one go to reduce risk and that kind of thing. So I think that's a major part of it. I think if people would set up shop now, they would look at this differently. I'd hope so, or I'd certainly show them that piece of software here and say, hey, there's other ways of doing it. So I just think it's legacy stuff, and it just takes forever to change.
I have a question. What's the nuclear scenario after the merge if we have a good amount of consensus diversity with the clients, but then we still have Geth as the supermajority execution client? Right. We would be sort of in this scenario, the inactivity problem. So instead of here 56%, we would put 80. I guess you could even modify this for consensus for execution layer, and then you'd be in an activity leak scenario again. So yeah, that's bad. I would maybe call it a conventional war to stay in the analogy. So it's not as dramatic, but still really, really bad. Any other question? Well, I guess that's it. Please give it up for Freddie. Thanks. So this was the last talk for today in this room. We still have one talk downstairs in the concert hall. So if you guys want to go there, we'll have I believe it's staking in 3 levels. And I believe it'll be very interesting for everyone.